Hello class. Today we're going to look at 7.5, the last part of 7.5, trig equations with multiple angles. Now we have seen equations like this before, like we solved this one where we had sine 2 theta. And we used an identity, and the reason we need to use identity there is because there's only a theta there. So today we're going to look at some other equations, and we might look at this one, sine 3 theta. We don't have an identity for that, but it only occurs there. And we also are going to look at an equation where we have the 3 theta in two different places, but all the angles are in terms of 3 theta, so it'll work out for us. There's also this equation where we have theta over 2 instead of theta. Now that'll work. The methods today, I'm not going to do this example. If you want to see this example, look at example 6 on page 527. So the first one we're going to look at is this one right here. Example 1. We have sine 3 theta minus 1 equals 0. That's given. Okay, so since we just have 3 theta, we have the sine of 3 theta, we can switch to x's and y's. I'm going to do that. Sine is the y, so that we have 2y minus 1 equals 0. We could do that. We just have to know y equals the sine of 3 theta. Our theta here is now just going to be replaced with 3 theta. We'll get to that. So we solve this. So add 1 to both sides. We get 2y equals 1, divide both sides by 2, and we get y equals 1/2. Okay, just like before, we find that on the unit circle. Where does y equal 1/2? And the y coordinate is 1/2 there. And we could look at it on the table, or we could remember, I think about that little triangle, the 30, 60, 90 triangle, where this side's 1/2. So that is pi over 6, and this is 5 pi over 6. Now we have the two solutions. Let me write them down. Instead of theta, I have 3 theta. And 3 theta equals pi over 6 plus 2k pi. And I have theta, 3 theta, equals 5 pi over 6 plus 2k pi. So these are my two general solutions, although I need them in terms of theta. Now to do this, since I have fractions involved, when I'm dividing by 3 on both sides, it's the same as multiplying by 1/3. So I'm going to put that 1/3 here. And I have pi over 6 plus 2k pi. I'll put it over 1 so I can distribute easily. And on the other one, I'm going to have theta equals 1/3. Have 5 pi over 6 plus 2k pi over 1. Distribute that through, so they get theta equals pi over 18 plus 2k pi over 3. This multiplies in. And this one I get theta equals 5 pi over 18 plus 2k pi over 3. So these are my general solutions. So now I'm going to actually find, because the book will ask us to find solutions, find all solutions on the unit circle. So that would be the interval from 0 to 2 pi. We'll include 0 but not 2 pi because 2 pi is the same as 0. So if it ends up being there. Now what I'm going to do is I'm going to take these solutions, I'm just going to generate the rest. So I'm going to start with pi over 18. Now I'm going to add 2k pi over 3 to that. But since the denominator is 18, I'm just going to say that 2 pi over 3 is the same as 12 pi over 18. So I'm going to add multiples of 12 pi over 18 to this. Generally, that means I'm going to add multiples of 12 to this 1. So 1 plus 12 is 13. It gives me 13 pi over 18. And another 12 gives me 25 pi over 18. Add another 12, and that's 37 pi over 18. Although I should remember that 2 pi is equal to 36 pi over 18, and I don't want to go past that. So there's 3 solutions. Now I'm going to take my other solution, which is 5 pi over 18, and I'm going to add 12 pi over 18 to that. So plus 3, 12 is 17 pi over 18, plus 12 is 29 pi over 18, and plus another 12 gives me beyond 36 pi over 18. So these are my solutions that are on the unit circle.